Chapter 7, RIPv2. RIP version 2 is defined by the RFC 1723, and it is our first classless routing protocol that we're going to discuss in this course. We will discuss others. The figure on the right shows where RIPv2 stands in the table between the classful, the classless, and the IPv6 routing protocols. It is not as popular as some of the link state protocols and the other distance vector protocols, but it is still in use today. While it may be less popular than other routing protocols, both versions of RIP are still appropriate in some situations. RIP lacks the compatibilities of many of the later protocols, but just because it's so simple to use and its widespread use in multiple operating systems makes it an ideal candidate for smaller, homogeneous networks where multi-vendor support is necessary, especially within a Unix environment. Because you need to understand RIPv2, even if you don't use it, this chapter is going to focus on some of the differences between RIPv1, which is classful, and RIPv2, which is classless. RIPv2 is actually an enhancement of RIPv1 and its extensions rather than entirely a new protocol. Some of the enhanced features include next hop address included in the routing table, the use of multicast addresses in sending updates, and authentication options available. RIPv2 does use your subnet mask. Like RIPv1, it is a distance vector routing protocol, and both versions of RIP share the following features and limitations. They both use of hold down and other timers to help prevent routing loops. The use of split horizon or split horizon with position reverse to also help prevent your router loops. The use of triggered updates when there is a change in the topology for faster convergence, and the maximum hop count limit of 15, with the hop count of 16 signifying that the network is unreachable. Make sure that you review the lab topology that is set up on the online access. You'll run through it and you'll see how the lab is going to be set up throughout this chapter that you're going to use. It'll show you the different VSLMs, how the addresses were acquired. It's going to explain a little bit about loopback interfaces. And basically loopbacks are going to act as if they are another network, but it is a software only interface, and it just looks like it's a physical network, but it is not. And we will use these throughout this course. Be sure that you have gone through and read the section on the RIPv1 limitations so that you understand those. I'm not going to go over those because we've just completed a chapter on RIPv1 and it should still be fresh in your memory. Although RIPv2 has the same basic message format as RIPv1, there's two significant extensions are added. The first extension in the RIPv2 message format is the subnet mask field that allows a 32-bit mask to be included in the RIP routing entry. As a result, the receiving router no longer depends upon the subnet mask of the inbound interface or the classful mask when determining the subnet mask for a route, because you've given them the subnet mask. The second significant extension to the RIPv2 message format is the addition of the next hop address. And the next hop address is used to identify a better next hop address, if one exists, than the address of the sending router. If the field is set to quad 0, the address of the sending router is the best next hop address. By default, when you enter router RIP, it goes automatically to version 1, and you're going to have to tell it that you're wanting to use version 2, and this needs to be done on all the routers in your network. So you'll notice here in this example that it says the default version control that we're sending version 1. The command you key in is router RIP, just like we did before, but this time you're going to key in version 2, and this changes your RIP from RIPv1 to RIPv2, and you'll do it on each router. Then when you show your IP protocols, you'll notice that it now says that the send version is 2 and receive version is 2. If you should happen to turn on RIPv2 and then decide you want to go back to RIPv1, you just key in router RIP version 1 and this resets your version to version 1. Keep in mind that by default, RIPv2 automatically summarizes networks at major network boundaries, just like RIPv1. You can turn off AutoSummary in RIPv2, and the command to do that is no AutoSummary. This command is not valid in RIPv1. You'll get an error if you're currently in version 1. You have to be in version 2 in order for you to see this. Once automatic summarization has been disabled, RIPv2 will no longer summarize networks to their classful address at boundary routers. RIPv2 will now include all subnets with their appropriate mask in its routing table. And the command show IP protocols can be used to verify that the automatic network summarization is not in effect. You'll see that here where it says automatic network summarization is not in effect. Because classless routing protocols like RIPv2 can carry both the network address and the subnet mask, they do not need to summarize these networks to their classful addresses at the major network boundaries. And classless routing protocols support the VSLM routers using RIPv2 no longer need to use the inbound interface's mask to determine the subnet mask in the route advertisement. That's because they include the subnet mask in their own. The network and the mask are explicitly included in each and every routing update. And when this happens in the network with VSLM addressing scheme, the classless routing protocol is essential to propagate all the networks along the correct subnet, along with their correct subnet mask. With RIPv2 and SIDR, one of the goals of the classless interdomain routing, or SIDR, is to provide the mechanism for the aggregation of routing information. Basically, we're going to create a supernet. And a supernet's a block of contiguous classful networks that is addressed as a single network. And contiguous just means that they're sequentially in order. On the R2 router, we configured a supernet, a static route to a single network that's used to represent multiple networks or subnets, and you can see that to the right. Supernets have masks that are smaller than classful masks. Let's say a /16 here instead of a /24. For the supernet to include in a routing table, the routing protocol must have the capability of carrying that mask. In other words, it must be classless routing protocol. So it would not work with RIPv1 because it is classful. You have verification and troubleshooting commands. We have show IP route, and that shows the different routes on your router. You have show IP interface brief. We're used to seeing this one so that we can tell if our interfaces are in an up or down state. Show IP protocols. This is going to show us which protocol we're running and which version. So on this one it is running RIP and it has running version 2. Our debug IP RIP helps us track down problems or see exactly how things are running. Ping lets us test to see if we're making connections. And of course our show run config, we can see what we actually have set up in our configurations. Some of the common RIPv2 issues that we have that you need to troubleshoot for are the versions. A good place to begin troubleshooting in a network that's running RIP is to verify that version 2 is configured on all your routers. Again, if you don't have it configured on all the routers, they're not all using the same language basically. The network statements. Another source of problems might be incorrect or missing network statements. Remember, the network statement does two things. It enables the routing protocol to send and receive updates on any logical interface that belongs to that network. It also includes the network in its routing update to its neighbor routers. Any missing or incorrect network statement will result in missing routing updates and the routing updates not being sent or received on a particular interface. Also, automatic summarization. You need to make sure that you have no AutoSummary turned on if that's how you need it to run, or have automatic summarization disabled. You'll need to pay attention to the authentication section of this chapter. As it points out, most routing protocols send their routing updates and other routing information using IP packets. ISIS is an exception, but that's beyond the scope of this book and this course and even this program. That's a CCNP topic. A security concern of any of the routing protocol is the possibility of accepting invalid routing tables or invalid routing updates. The source of the invalid routing updates could be an attacker maliciously attempting to disrupt your network or trying to capture packets by tricking the router into sending its updates to the wrong destination. Another source of invalid updates could be misconfigured routers, if you fat-fingered something, or perhaps a host is attached to the network and, unknown to its user, the host is running the routing protocol of the local network. So pay attention to this chapter, this section of the chapter. There is a packet tracer you can attempt if you like. I don't have any packet tracers assigned for Chapter 7. You will need to do the basic RIPv2 configuration. In the lab you will work with a discontiguous network that's subnetted using VSLM. You can also do it in Packet Tracer, but I will not accept the Packet Tracer file itself. I need for you to do them in NetLabs. You have the challenge RIPv2 configuration that you're going to do in NetLabs or Live Labs. And again, there's a Packet Tracer if you want to practice on it. Same goes for the troubleshooting. Be sure you go through the summary. It's very helpful to go through the summary when preparing for the exam. You have the summary review. There is this integrated packet tracer. It is not assigned, but it's there for you to do if you so choose. There's another section here with summary and reviews. And then the chapter quiz is real good for you to take. No one sees these scores but you, but it will help you get prepared for the quiz at the end of the chapter. Good luck with Chapter 7 and RIPv2.